y equals x cube. Now this is also a polynomial called as a cubic function. So how do we differentiate it? And what is the first principle? How do we apply on it? So y equals x cube, I am just making a random curve. So in order to find out the differentiation, we have to find out the slope or the gradient of the tangent. But we have to take 2 points. The first point is x1, y1. So if x is x, y will be x cube. And since 1 point tangent difficult to get, so we formulate or we try to find out another point b. And finally, when we solve everything, we combine a and b, that is a on b. So we are just adding a little bit because we want to find out the slope, that is only instantaneous value of x changing with y. So x plus delta x, and then the y point will be x plus delta x whole cube. So what we will do is delta x tends to 0, then a and b will coincide. 2 points we have taken to find out the slope, to find out the gradient of that line. But we have to make it as 1 because the tangent at that point will give you the differentiation, will give you the gradient, will give you the slope, right? So the gradient of the chord, please remember the chord, that is the line touching 2 points of the curve. So y2 minus y1 by x2 minus x1, this is the gradient, this is the tan theta, this is the slope. Okay? Now what we'll do is y2 we know, these are the values. So x plus delta x and by x cube minus y y2 minus y1 by x2 minus x1, that we will do. Okay, simple. So this x gets cancelled, and finally we have a plus b whole cube formula. So a cube plus b cube plus 3ab a plus b. So when you apply this formula a plus b whole cube, x cubes get cancelled, and delta x you can take common. When you take delta x common, you have delta x in the denominator, it gets cancelled. So this delta x wherever it is. Finally we will apply the limit. Why we are applying the limit delta x tends to 0? Because we have to coincide a and b point, we want the tangent. So that a and b distance should be at least if not 0, equivalent to 0. Right? So this is to go into your mind. We want tangent, not the chord. So we are making the chord and ultimately making it as a tangent. By del y by del x tends to 0. This comes as 3x square because all other term when del x equals 0 becomes 0. So y equals x cube. The differentiation of this y equals x cube is nothing but 3x square. So this limit x tends to 0, delta x tends to 0, del y by del x is nothing but dy by dx. Okay. This is 3x square by first principle, the differentiation. So the gradient of this tangent of y equals x cube we just found out at any general point. You can take any point on the curve and you can tell this is the instantaneous value of this curve at this point. So dy by dx is x of x cube is 3x square. So fx, the function was x cube. Now there are various ways to represent it. That is f dash x is the gradient of the tangent, and that is going to be 3x square, and this is also the differentiation. The differentiation is represented by f dash x. So in order to find out the gradient of the tangent of curve this y equals x cube, say at point minus 2 minus 8, f dash x we already found out, this is going to be dy by dx also, that is going to be 3x square. You just have to take this minus 2 value, put it here, and then 3 into minus 2 whole square is 4, it is 12. So f dash x is 3x square at the point minus 2 and minus 8 or negative 2, negative 8, you get f dash minus 2 as 12. Now you have to give me the answer why the gradient of fx equals x cube is always positive.